Greetings. So this is a little bit different view of me doing a video for you guys. I'm sitting in my office and I need to do some videos dealing with cubic equations, but I also need you to see what it is I'm going to do. So in that light, I decided to do a screen capture, but I'm going to do it with Zoom open so you can still see my face and kind of see what the expressions are and what's taking place. So the first thing I'm going to do is I'm going to get my little face over here to the side. And we're going to begin with this particular screen capture. And you're going to see why I'm doing this. So first thing I'm going to do is I'm going to highlight this. I have a function over here, x cubed plus a distance a times x squared plus a distance b times x plus c. And these little segments I have over here control these measurements. And so I can change C in this equation. And right now we see that C is negative, and that's where our y-intercept is. And if I were to make C positive, I would have a positive y-intercept. But I can also change the linear coefficient. And that has a change on what the shape of the overall function looks like. I can also change a, and having either negative values of a or large positive values of a give me the typical cubic equation shape where you get what I call the zigzag in the middle of the graph. So the reason I do this is I want you to understand why is it that we want to play with the square. Because remember, in solving the cubic equation, we get a cubic equation where we have coefficients on x squared, on x, and a constant. But when we do what Tartaglia and Cardan do, we're going to get rid of the coefficient on x squared, which means I need this coefficient to go to 0, and I want you to see what happens when I do that. By making that coefficient go to 0, or as close as I can get, and that's about as close as I'm going to get. Notice what our shape is. Our shape loses what I call the zigzag, and it gives us exactly one solution to the cubic equation. And notice b is positive, and as long as b remains positive, we have this shape. And remember, I have C over here on the same side as all of my X information, so that means C must remain negative in value. And notice C only makes the curve slide up and down, and as long as C is negative, it means that my solution for X must be positive. This is why we did the reduction or suppression of the squared value, was so that we would make sure we have exactly one solution and that solution is positive. Notice if b becomes negative in value, I can get back to this idea of having the zigzag. And that's why the early people solving these problems needed b to be positive. They may not have completely understood this because this idea of graphing on an XY plane isn't something that will be thought about mathematically until the time of René Descartes in the 1600s. But we as students today can take a look at this and see, oh, this is what we did. This is why we wanted to do this. And I wanted you to see a little bit of why it is we're suppressing the square and what it does for our curve. So I hope you found this illuminating.